Thank you, Mark. I appreciate it. So to follow up Nicole, from Microsoft and Miller, this is a collaborative effort, co-creating and how we can build out new SRPs, enable new applications to run at the edge. And how we're doing that with Intel is a meaningful engagement that we're going to highlight in this session. So thank you for your attendance, your time. If you look at it, AIoT, there's the cloud service side. As Nicole mentioned, Azure's been in existence since 2009. And when we look at where Advantech is at with regards to the Internet of Things, it's really connecting these cloud services and be able to make more elastic solutions at the edge. To be able to move some of the compute that used to be done in the cloud, maybe doing some of that deep learning aspect at the edge. But how do we do that? We do that through the collaboration of utilizing some of the IP building blocks from Intel. We're going to highlight that today. So this slide you'll probably see about 30,000 times when you're here at the summit. But if you look at Advantech, Advantech's been on this journey of intelligent system. And that started with what we originally called SUSE Access. SUSE Access was rebranded, and as it was rebranded into Wise Pass, we actually started to realize that we needed to do more than just over-the-air updates and remote management and monitoring. And we started to create these solution-ready packages, and we're excited to highlight those here at this event. In this presentation, we're going to talk a little bit about some of those SRPs in this presentation, and we'll follow on in a deeper dive with Michael and Cheese when he's on stage next. But again, the transformation that we're going through is highlighting some of the existing SRPs today, and those SRPs that are enabling AI at the edge. But the reality that I want to be able to highlight is each and every one of you that are here, there may be opportunities for us to collaborate and build out new, meaningful SRPs that can leverage some of these. And that's that co-creation strategy that we're. So why AI? Why are we so interested in AI? I read an article in Scientific Magazine that actually Alibaba in October made an announcement that they're going to make an investment of $15 billion in AI. They're going to build out 7 labs globally. So when you see that type of investment, it's astonishing, right? Well, why are they doing that? They're doing it because there's a big opportunity in AI. $125 billion is projected by 2025. This is a Merrill Lynch, study that's been done. So the opportunity in AI is massive. And in that opportunity, that's where we've seen collaboration and even acquisitions from Intel. Intel's what I consider an x86 CPU company. But when they made the acquisition of Movidius, they actually made a decision that, hey, we need to get into the world of video processing units to be able to capitalize and secure the hardware line. So protecting that core. And if you look at the collaboration between Advantech and Intel, we are protecting that core. We're actually building out more meaningful devices, leveraging some of the VPU architecture that Intel has, that Richard will highlight. But beyond that, and this is what's exciting, is the value of AI. The majority of it, over 56%, over half of the value of AI is in the services. So we can enable these devices to run AI, but the service opportunity, that's the real co-creation opportunity to do. If you're an SI, if you're an ISV, you can create meaningful APIs that can run on these devices securely at the edge, create new meaningful revenue for you and your business. This is why we have the Co-Creation Summit. It's to be able to enable you to provide a trusted platform to go and scale your business, to be able to address your customer requirements, maybe transform your factory with new machine learning at the edge. So with that, I'd like to transition over to Richard from Intel. Richard, he comes here from Chandler, Arizona, and we're excited to hear what Richard has to say about the investments that Intel is making, how they're actually bringing AI to you. Richard?
All right. Good morning, everyone. it is my pleasure to be here, and thanks to Advantech to put together a big event like this, and let us to share our vision in the AI market, right? So, like Sean said, I'm based in Arizona, and I actually moved there like two years ago. And this year, I come back to Asia like 6 times already, and 2 weeks later, it will be 7th time for me to come back to Asia. My role is to design the next gen, like computer vision solution in Intel, and also our deep learning accelerator in Intel. So it depends on how frequent I come back to Asia, talk to a customer. You can see how we put so many resources and focus on this markets and also product design. So our product manager or program manager, they actually told me that, well, we need architect to stay in the US to keep designing the product, right? Not flying over the world. Otherwise, you should relocate back to Asia, right? So I don't know. So these 2 slides is just to get the overview of my title. Right. So we have many different numbers right now available in this market. So I want to point out, some numbers. I know Microsoft also have their own number, and we have our number. I actually found out that they are pretty consistent. So you can imagine that how much data you can collect, measure in a city scale. Even if you are driving a car, how much data that could be generated daily by 2020. So these are the numbers. And they are so big, right now I don't even know how to describe it, right? So petabyte, don't know what is that. But we know if we're going to collect all of those data, right now we have sufficient IoT technology for us to collect those data, right? We measure data, we collect data, and we put analytics to get the insight from those data and apply it to our business, apply it to our use cases, and to provide better service to customers, right? And how do we do that? If we're doing it today, the scale is not so big like this. But maybe 2 years, 3 years later, we're going to run into some challenges. So that is why, Intel, we want to, enable the smartness everywhere, not only in the cloud, but also in the edge. So depends on what segment that you are using. Deep learning or AI can actually be utilized in many different use cases. And like video, you can actually utilize the video solution in almost all of these use cases. And right now, the deep learning solution is mainly focused on video, right? And very soon, we're going to focus on like audio processing, natural language processing, to enhance the service that we can provide to customers. So like retail, that is the fast booming segment, right? You want to know whether your customer is happy enough. In the past, if you use like traditional CV to design the algorithm to extract, what's the emotion of your customer, you will have to design a number of filters for the faces. And actually, the result could be pretty ambiguous because it might be like 60% happy, but 50% unsatisfied. I don't know what is that, right? So for deep learning, the algorithm design, the complexity of algorithm design can be removed, not completely, but make it easier as long as you have enough data, right? So you have good data sets, amount of data sets, and you have labeled data, then you can actually tweak the deep learning model to understand the data itself. So you don't really need to tweak the parameter by yourself like traditional CV does. So using the deep learning, you can easily determine, where is the customer, are they happy, what kind of interaction or action they are doing in the store. You can do all of that in parallel, right? And the same goes to all other segments, right? And because video is the primary data source for deep learning application. So if we do everything in the cloud, you will have to tolerate like latency, and you have to take the overhead of networking. All of those, if you consider like petabyte scale, doing everything in the cloud doesn't work. So I think Intel and Microsoft actually right now the strategy is aligned. We want to move the intelligence to the edge. So in the past, you probably need a big server or a rack server to be able to do analysis or to provide a deep learning capability, right? But right now, with like in the new software stack that Intel provides, you can actually run the deep learning inferencing task on CPU in a very efficient way. You don't really need to install a discrete graphic card or 15 watt or 20 watt devices to have deep learning capacity. Right now, even if you are using Atom, right, the entry level CPU, like 5 watt device, you can have very good deep learning inferencing capability on that system already. So we want to move everything, the intelligence, the deep learning capacity to the edge, so that we can ease the latency constraint, the bandwidth constraint that right now we already start experiencing in the real world deployment. So that is our strategy, making everything intelligent. And if you look at the whole end-to-end solution, you will see these devices, right? So at the edge, you have camera, you have the device that can produce data, even your laptop, right? Those are your data source. And in the past, if you do not have like a co-processor, actually you cannot do any deep learning inferencing in the most efficient way. But Intel, we want to enable those devices to do deep learning inferencing. And also, for the edge server, which is a very important piece, we will have the deep learning accelerator that can be put into this pillar. And also, those accelerators can work in a backend data center, right? So we want to provide a full end-to-end story for the deep learning market, right? And I believe Intel is the only one company that can provide you all of the ingredients that can adapt from the edge to the backend server. So if we get into a second level detail about what to be used at different pillars. So at the edge, we have like Atom or co-processors centered on. Those processors right now are pretty good, like I said, to run the deep learning workload on the CPU only. All you need to do is to use your free, unused CPU cycle, and to run the deep learning workload on it, you can get pretty good performance today. So the cost is lower, the energy requirement, the power requirement is lower, so it's very good for you to enable, your smart edge device. But if the deep learning workload that you're going to deploy it at the edge is too heavy. It's too heavy that maybe CPU or our jet graphics cannot take the load. Then you definitely have the option to combine our CPU with our Movidius chips. Movidius VPU, Vision Compute Unit, is the deep learning accelerator that you can actually run your deep learning topology on the ASIC in a very power efficient way. So the wattage can be 2 watt and provide you very good performance. That is multi-channel, like 3-channel or 2-channel of video processing. Right? And because this is a small ASIC and it is very power efficient, depends on how many, how much workload that you want to implement at the edge. You can decide how many, VPU you want to put inside your box. All right, so you have choice. It is not like, oh, you have to buy a very expensive, very powerful device and put it in the H2 boxes in order to get deep learning capacity. No, you can decide. CPU, not enough, then 1 VPU or 2 VPU, your choice. All right, so you have many different options. And for the H server, so we are mainly, promoting like, Xeon, E3, E5, Xeon XP, and if you really need a deep learning inferencing capacity at the edge server, we have many different options that I'm going to mention later. That is, comprised by the Movidas chips and the Intel FPGA, like Area 10 as an accelerator. And for the backend, you definitely can use those accelerators in the backend. But like FPGA, we will mainly targeting like Stratus 10 scale of the FPGA, so that you can get the accurate performance to pair up with the CPU. So, like 2 weeks ago, we actually officially launched the Intel Vision accelerator design. So these are the accelerator cards that you can put into your system, and those cards are available in many different form factors. So like M.2 or mini PCIe, you can have 1 or 2 VPU on the module. So if you have free available unused mini PCIe or M.2 sockets, then you can definitely put one of those modules in a small box. And then you can process like 2 to 4 channel of video with deep learning inferencing capacity. Those are pretty good. But if I want high density, a very high throughput deep learning inferencing capacity, then what should I do? Right? So we also come out with we call it the Movidas card, the PCIe form factor. We have 8 VPU on the board, so it can provide you very high throughput on the deep learning inferencing. And also we have another version that is Area 10 FPGA, Area 10 FPGA accelerator. So these two cards are mainly targeting to if you want to use a discrete GPU kind of solution, then you can consider this too, because we purposely, intentionally make these two cards to be very cheap and very power efficient. So if you're considering like low wattage of a box or lower total cost of ownership, then Movidas VPU cards or FPGA card will definitely be the best option that you can have. Right, comparing, everyone wants the comparison, right? You say you're so good, but what's the number, right? So if we compare like CPU, FPGA cards, our Movidas cards to the discrete graphics. For CPU, the performance per dollar is 2.3x compared to discrete graphics. The reason is that you don't really need to add any additional card, but you can run deep learning on it. And if you're choosing like an FPGA, it would be 1.9x performance per watt per dollar. That is what end customer care about. And if you're using like a Movidas card, it would be more than 3x. And the difference between these two cards is that a Movidas chips is an ASIC, so you want to run the algorithm that is available, optimized by on the VPU, and FPGA is flexible, so you can actually accelerate non-deep learning workload on FPGA together with the deep learning IP. Right? And we also have the small form factor, M.2 or mini PCIe that is also better than discrete graphics. So we have the OpenVINO software stack because we have so many different options. And OpenVINO actually provides you a single framework to access those hardware accelerators. So you don't really need to worry about, do I need to deal with multiple APIs in order to use those hardware? No. You just use OpenVINO. It is freely available on the web. And like last week, we actually open sourced the software package to the world. And we actually working like Intel, Advantech, we are working really close together to come out with the M.2 mini PCIe VPU cards. And that is the starting point of this design, because we're going to have like 8 VPU on the card and FPGA card design with Advantech very soon, so that you can actually get the full product portfolio of this accelerator from Advantech. And you can actually deploy those hardware to many different segments like retail or traffic monitoring. Those are all doable, actually. These are very horizontal platforms. And Intel, we committed to this AI market. So not only we enable the frameworks, we also work with like Microsoft to enable IoT Edge on all of these parts, so that you can actually deploy your deep learning workload to the edge device with these cards. You will run it, and the manageability actually is a lot easier for you to deploy your workload to the edge. Right. So this is all material that I have, and I will be around here like in the next 2 days. So if you are interested about Intel products or Intel Deep Learning Accelerator, please come to me. I can share more detailed information with you. Thanks a lot.
Thank you, Richard. So I think, the way I want to go full circle. So we highlighted again some of the Intel building blocks that they've brought to bear with the VPU and FPGA building blocks. But if we look at Advantech, again, what we've been able to do is take some of the core embedded devices that you've seen typically like in our ARC series of products, integrate some of these IP building blocks from Intel with the VPU, for instance, the NVIDIA's VPUs, and be able to create new meaningful SRPs. So today, you're going to be able to see these SRPs demonstrated. And after this presentation, will be a little bit deeper dive from my counterparts from Europe, who are going to go deeper into some of these different solutions. But why did we do this? We looked at it. Our goal is to shorten that time to money for you and your customers. So you can leverage a lot of these existing known good ingredients, these solution-ready packages, so that you can gain access to data and you can make more informed decisions inside of those applications. But that doesn't mean that you have to use this as is. The capabilities as us as ecosystem partners, as us doing co-creation, we can modify these ingredients to really resonate within your space. So if we look at that, what are we doing? The tenets of IoT co-creation is creating the WisePass EdgeSense, which is a smart edge management software package from Advantech, and being able to incorporate third-party application software services where needed. We give you that vehicle to be able to onboard your application. We have partners here today, like Zadata. I know Zadata's here. Thank you for joining us. They came from Santa Clara. They run hypervisor on VMs at the edge, be able to run multiple APIs inside of workload consolidation securely in a manner that we haven't seen at the edge. We used to be able to do these things in the background, but now we're able to onboard and enable some of these different co-creation strategies. But if we look at the edge intelligence, again, those SRPs, we want to look at those as opportunities for you to get them out of the box, be able to integrate your sensor, be able to actually run these fairly quickly. And if we look at it again, we want to re-highlight some of those different embedded building blocks. So Richard talked about the M.2 form factor, the VPU, scaling to mini PCIe and PCIe, and all the way up to an FPGA card. Those are off-the-shelf solutions that you can buy from Advantech, and you can deploy in your system. But if you want, you can also take the actual systems that we have and be able to start with an overall intelligent system from the edge, be able to run your inference systems today. So if you look at the embedded AI software packages, I talked about an elastic edge. In the past, a lot of the AI and deep learning was done in the cloud. But with these new capabilities that we have with the collaboration from Intel, Microsoft, and others, we're able to move these inference systems to the edge to make it more elastic. And you can build off of that. And we're seeing that these applications are meaningful in retail, smart manufacturing, and transportation, and there's going to be many more. And with your collaboration, that's how we would take these new solutions to market. So one of those is the license plate recognition. So with the Movidius VPU, being able to do people counting, as Miller highlighted earlier this morning, being able to do new meaningful solutions in smart cities. So this solution has been put together by Stefan and his team at Advantech, running the Movidius VPU with the OpenVINO toolkit. We also have the equipment vibration monitoring solution. This is from a partner called NCAP. PhDs who focus simulation software on vibration analysis. Being able to take their expertise, their domain-focused expertise in vibration analysis, and putting that API in the edge, in our edge device, be able to run meaningful vibration analysis, predictive analytics at the edge. We'll highlight that in a solution that we have an example here. Next slide. So this case study for edge vibration management solution for predictive maintenance was actually done in semiconductor manufacturing. And what we're looking to do is enable real-time vibration monitoring at the edge. And again, Richard talks about the latency that you see with some of the devices that have to send information back to the cloud. And being able to do that in real time is critical to success, especially when you're talking about high-value assets like in a semiconductor manufacturing environment. So today, we were able to solve this pain by actually using a legacy solution which did all the analytics in the cloud. So this case study, we were able to reduce maintenance costs by $3 million per year, increase the utilization rate from 98.4 to 98.98, 99%, but more importantly, reduce the downtime from 72 hours of maintenance to 8. How do we do that again? It's through that vibration monitoring and analysis. Being able to do that vibration monitoring at the edge with the smart sensor that we have created with NCAP and integrating that into a solution-ready package, we're able to do this end-to-end, again, sensor-to-cloud solution. But what I think is interesting is we have a use case today with a food processing plant in Michigan. It's a major food company. I can't mention it because it's under NDA. We're in a POC state. But they want to actually do 6 different types of sensing applications at the edge. One is vibration monitoring. They also want to do machine learning. They actually want to inspect the food, see the size, shape of the food as it's coming off of their food processing line. That has a huge amount of waste. So the thing that I'm excited is being able to take this type of use case, integrating the VPU into the SRP, and being able to add new outcomes, right? Be able to do machine learning at the edge, be able to see that food as it comes off that processing line, and be able to determine is it good or is it bad, as well as doing vibration monitoring. So these are new applications that we can bring to bear by leveraging some of these different building blocks that our partners from Intel have been able to bring. So we're excited. So we call that workload consolidation. Instead of just having a device that's dedicated to doing one thing, we're in a real case scenario right now. We're under POC. We're actually doing 6 different things on that one edge-based device, sensing 6 different things, and doing machine learning. So it's exciting where we're going with these solutions. So what we'd like to do, the call to action here, is really, it's one thing to see slideware, right? But it's nothing like to actually see these devices in action. We encourage you to go to the actual exhibition, which is on the 3rd floor, and actually see the booths. So we have 3 different areas. The intelligent solutions, which is set up. We have the domain-focused edge and AI solutions we talked about here in this topic. And then lastly, the AI platforms. So please, don't just look at slides. Go see the actual devices, see them working, and be able to talk to the owners of those different platforms. Thank you.